So, welcome to the last presentation in the tech room. I guess you're all tired. This is going to be a little bit of a heavy talk, so you could fall asleep. I'm going to talk about style recalculation optimizations that has been done working on this year. So this is me. This is actually 10 years ago when I worked at I was already working at Opera at that time. I've been working on the Presto engine for many years, and after we switched to Blink, I've been working on CSS and layout in Blink. Not that much layout yet, but. So what is style recalc? So when you load a page, the first time you attach the render tree, you have to calculate the style for every node that needs a render object. But then afterwards, when the user starts interacting with the page, the computed styles or the render style will have to be recalculated when the DOM mutates, when you change attributes. So that's what I call style recalc. So typical changes is ID attribute changes, class changes, other attributes, various pseudo classes, and modifying the DOM tree. So the motivation for doing optimization at all. There's jank. And if we spend too much time in style recalc, you will, in particular on mobile, you will see jank. So this is actually not very smooth, the smooth one either. I'm actually using not web animations, CSS animations here just to illustrate. So there might be some possible optimizations on this page. And I'm going to show you a little bit of what happens on the timeline for recalc style and what used to happen and what happens now on a specific page. You see this? So for the initial hover on this page, here I'm actually looking at Opera 20, which uses an older version of Blink and Chromium. You have an 18.605 millisecond style recalc of 1,646 elements just on initial hover on the page. And I'll get back to why it is like that. Now, this is Opera 21. Can't actually see the numbers here yet. Yeah, let's try again. This is a single element recalc. So this is exactly the same thing in with some optimizations included. So when you optimize, there are several ways to optimize. You can do less work, do smarter algorithms, or you can just use your current algorithm and do things faster. When optimizing style recalc, you could try to be smart and recalculate style for fewer nodes. You can do faster recalc per node using, for instance, CSS selector JIT that I think Jochen has started working on. Are you here, Jochen? No. So in Blink, we also use style sharing, which is you detect a similarity between certain nodes, have the same attributes, etc., same parent, and based on that, you just clone, or you actually use the same render style. So you don't have to do any selector matching or anything. And the last thing I mentioned here is smart partial recal for Element.style. That's not implemented yet, as far as I know, but when you change the style declaration or the style attribute on an element, you, in some cases, you don't need to look at the selector matching at all, in theory, but we actually do that. So the assumption here is that we are way too eager to recalculate style. And the ultimate goal is that we should only recalculate style on the nodes that we really have to do it for. But that means that we need to know a lot about our selectors in order to be able to do that. So why is it so hard? Why can't we just figure out exactly which nodes we need to recalc and then do it on all those nodes? Yeah, the major problem, as I see it, are combinators. Combinators and selectors makes it possible to address style on nodes that are far from the node that actually gets a change that changes the valuation of the selector. So take this example. Here we have an indirect adjacent selector, which makes you select the class A on the div to the left. If you set that class A on that div element, it will make the selector match the div down to the right with the class B. So they are in quite different parts of the tree, and doing a modification on that first div, how can you figure out that you're only affecting that div on the lower right edge? So these are the nodes you actually affect by setting the class A on the first div. But the Blink currently recalculates style for all of these nodes. And the reason for that is that we don't have the information in the selectors to be able to decide that it's only that B on the lower right-hand side that's affected. Now, there have been some improvements, but but for certain selectors, it's still heavy. Yeah, so this is basically the text saying how many elements we need that can be affected by a certain combinator. So in the beginning of 2014, we started to do some things to to make us consider fewer nodes when we were recalculating styles. At the end of 2013, we always did a subtree recalc for all of these cases. I'll get back to what the subtree recalc is later, but it basically means recalculate the whole subtree of the node that you're changing, but also you need to consider some sibling trees. For changing the style attribute, in 2013 you would do a local style change. And the reason for that is that when you change the style attribute, you don't need to reconsider any selectors. So changing the style of one element wouldn't affect the styles of any other elements, apart from the fact that you need to inherit down the computed styles if some properties are inherited. So there was a tiny optimization. The fact that if you set a class ID or attribute that wasn't present in any selector at all, you wouldn't do a recalc style at all. But normally when you set the class or any other attribute on an element, you have a CSS rule for it that will actually affect the computed styles anyway. So classes, IDs, attributes are one thing. Pseudo classes are handled a bit differently in Blink. During the selector matching, you actually mark RenderStyle objects and elements with a bit saying that we're trying to match hover styles for it, but if it isn't hovered, we still set a bit on it so that we can remember until we update the styles for hover that we need to recalc style on it when hover state changes. So when you have a hover in the rightmost part of the selector, you mark a bit saying that it's affected by hover. But if it's like you have a descendant selector, where you have a hover to the left of the descendant combinator, you would mark the element that actually would have matched the hover pseudo class with affected by children bit, which means when that changes its hover state, you have to recalc style for all of the descendants. So these are the style change types that come from attribute changes and pseudo style changes. So there's a method called setNeedStyleRecalc. I think it is on Node. And you call this method on an element when you think that we need to do a style recalc for it, and what type of style recalc we need. One of those from the last slide. All these style change types done on elements are batched. So before the next layout, we'll do a tree traversal doing recalculation of the nodes that are marked and need to be recalced. So local style change means on a node means recalculate style for this node and propagate inherited properties. In 2013, we almost exclusively did this for Element.style changes, which means we did subtree recalcs for a lot of or most of the changes. As I said before, SubtreeStyleChange recalculates styles for the whole subtree, and it might be a lot of sibling trees as well if you have sibling selectors, or in the worst case, an indirect adjacent selector. Yeah, there's a reattach style change as well. That's the change that is set on node initially when you haven't attached anything. And if you need to reattach the render, it will be set from node detached. That's the only place that happens. So 2014. Yeah, I got involved because we had a phone conference with some people from Google and asking how can we contribute to the Blink project, what is important. And the answer we got was, for instance, look at hotlist jank. So on that hot list, there was some focus update problems. I think Eric did a CL there where he introduced these affected bits for focus as well as hover and active. But there was a comment in there, fix me, saying that shouldn't we do local style change for affected by? So I tried to do that, and then there were a few regressions in the layout tests. It turned out somebody had actually tried that before. I think Elliot had tried it before, and he just didn't try to fix those regressions or figure it out what it was. Yeah, these four pseudo classes are the ones that are done the same way using these affected bits. Yeah, I'm doing some magic here in the presentation. I actually programmed these trees in JavaScript using some JavaScript script library. So what I'm showing here is when setting these affected by bits, we try to, before we have any hover state, for instance, we mark these bits, as I mentioned before, on the elements where we cannot match the hover, but we mark it for later. So in case it gets the hover state, we know that we need to update it. So in this case, if you look at the span, we try to match up the tree. We get to the first div. Try to match the hover on that div. Well, we don't match because we don't hover anything yet. So just mark the bit in case we hover it later. So in this case, those two divs will have this bit set. So the idea that Eric mentioned in his CL, or was to use local style changes instead of a subtree style change for pseudo classes when those pseudo classes are only present in the rightmost part of the selector. So that's what we've done. So that's actually now the case for focus, active, and hover, and that's what we actually saw on the demo I had of the timeline when we moved from 1600 something nodes that were recalculated and to a single node recalc, because the root or the body element actually were affected by, or we thought it was affected by hover, and before we started using local style for affected by, we did a full subtree style change for the whole document. So the reason why we got those regressions were because local style change was, it seems like it was somewhat made for the style attribute update. So when you have selectors in addition, it didn't work out because were some missing updates for pseudo elements, for instance. So I had to go into the recalc own style for the node and fix that, so that when you change the hover state for an element and you have a rule that also has a pseudo element for the hover rule, you actually need to go and check those pseudo elements as well to see if there was a content property applied based on the hover effect, for instance. First letter is still a subtree recalc, and the reason for that is that first letter style can come from basically any ascendant container, given that there's no text in between. Yeah, this is an example of the selector I mentioned. You hover the div, and if you have a local style change for that div, you won't get any style changes for that div itself, but you will notice that you actually got a content change for the before element, so that needs to be updated. Yeah, so the conclusion is that this initial hover focus an active problem is fixed on many sites. I mean, hover, it might not be that problematic on mobile, but focus definitely is. I've seen some sites where you try to tap inside a search field, and it is like a big delay before you actually get that that cursor up. So again, why do we need subtree recalc? And the reason is that if we don't know much about our selectors, and you have descendant selectors, you know that various classes and attributes are going to affect calculated computed styles for one of the elements in the subtree. So just recalculate the whole subtree and we'll catch it. So we need to know more about the selectors in order to do anything smarter. So after I did the thing for the pseudo elements, I thought, well, couldn't we do something similar for classes and IDs? Because we had this hash set saying that these certain IDs and these certain classes are part of selectors in some way. So if you look at the example here, the class B is only present in the rightmost part of the selector. There's no combinator to the right of the class selectors containing B. That means that we're sure that setting class B on an element will not affect the computed styles of any elements in the subtree, and we could use a local style change for that. But then, any questions? No. But trying to do that, I stumbled into some work done by Chris Harrelson in San Francisco, or yeah. And he said, come help us out with Descendant Invalidation Sets instead, which was sort of a similar idea, just doing a lot more. So Descendant Invalidation Sets, for those we try to do a selective style recalc in subtrees based on analyzing the selectors which are present in the style sheets. This is I think the initial idea was by Elliot Spren, and Chris Harrelson was doing a lot of work on it before I noticed it. So these invalidation sets are created when we, by processing the style sheets as they are added to the style resolver. And there's one set per class, and for a given class, we add a set of other classes, IDs, or attributes that must, in the case those are set on any descendant elements, you need to recalculate the styles on those elements. Oh, this is a lot of text. But this is basically the text saying how to construct those invalidation sets. I can show you some example selectors instead. So here we have a selector, two descendant combinators, A, B, and C class selectors. When we construct these invalidation sets, we look at the rightmost selector first, because the rightmost part of the selector is what is going to match some element for a given rule. So this rule is not going to contribute styles for elements with the A or B class set. It's going to contribute computed styles for the elements with the class C. So we extract that class C, and then for the other components of the selector, we add that class C to their invalidation sets. And we end up with the sets below. What this means in practice is that when you set the class A on some element, you need to go through its subtree, and for every element that has the class C set, you do a local style change for it. Similarly with class B, if you set that on any element, you need to go through its descendants and mark the elements with class C with a local style change. And for C itself, we get an empty set, which basically means you just do a local style change for it. You don't need to traverse your subtree at all. I have a different example here, and it shows something we do when we have several components of the rightmost selector. So this is something that really can be improved, because instead of matching the whole rightmost selector to figure out if we need a style recalc on a node, we split it into components and check each individually. So in this case, changing the class A on some element will make us invalidate all span descendants, even though we would only need to invalidate or recalculate style for those span elements that has the class B in addition. So this is not optimal yet. Yeah, more advanced example. One thing I can take from this is that if you see there's something called whole subtree, which is the fallback into recalculate the whole subtree for certain selectors, and we do that when we have adjacent selectors, because then you have the possibility of needing to recalculate the style for nodes in sibling subtrees, and the descendant invalidation sets currently just work for the subtree of the node that is changed. So that's clearly also something that can be improved. But we started with a whitelist of which type of selectors, which components that we were sure that this was going to work for. In the beginning, we didn't support certain shadow DOM selectors either, but that has been improved. So using these invalidation sets now happens when you do a class change or attribute change, where you earlier did a subtree recalc marking on the node. When you did that change, instead you schedule an invalidation with an invalidation set. So before we do the style recalc, all these scheduled invalidations are used to traverse the document tree and then set the style change type based on the invalidation sets. So here's another example. I have not listed the invalidation sets here, but for class B, it would be A. For class A, it would be C. And A and C would be empty. So running that small script where you set the class name A and B on those div elements, you will only recalc style for those two. And all the other ones would be skipped. But earlier, when we did the subtree recalc, you would do everything. So here's which style type changes you do on the element based on what your invalidation set looks like. Also, during the style invalidation traversal, you sort of use the union of the invalidation sets that applies to that part of the subtree. So if you go back to the previous one here, you would have scheduled the set containing C on that div A element, and you will have an invalidation set for yeah. Yeah, when you set the B class, you will have an invalidation set for that containing A, but that comes into action when you do the tree traversal down to B, which means it won't affect the A on top. But yeah. So doing this invalidation, if there is no invalidation set active, there's no change. If there's an empty invalidation set, it means that there is a selector for that class that you changed, but it always have that class in the rightmost part of the selector, so you only need to do a local style change. For the non-empty sets, you need to check each descendant element and figure out if they match any of the components of the invalidation set. And whole subtree, we fall back to SubtreeStyleChange and skip any invalidation of the rest of that subtree. Yeah, I mentioned a few exceptions, but this is not extensive by any means. Negated class selectors cannot use invalidation sets. And the reason is it's hard to test. It's hard to test that the class is, it's not hard, but you would have to be able to represent that in some way in an invalidation set, and now it's just atomic strings for the classes, so yeah, it could be extended, I guess. And the adjacent selectors do not work with invalidation sets because of those sibling subtrees I was talking about. And first letter I've also mentioned before. So currently we're doing a two-pass traversal over the DOM tree. We do a pass for mapping from invalidation sets to the style type change, and then we do the normal recalc style afterwards. I guess if you're modifying the class of body, for instance, and there is one single element that is affected by a selector for that class you set on body, You will only need to recalc style for a single element deep down the tree, but you actually do a pass through the whole dump tree to mark that with local style change, and then get back up and do a recalc style of the whole tree only to get down to that local style change again. And ideally, that could have been done in one pass, I guess, if you did invalidation and the recalc style in the same pass. Yeah, a couple of other possible changes too. So in order to recalculate the minimal number of nodes, you actually need to match all the selectors to be sure that I'm really sure that this node is not affected. I guess that's sort of too expensive, so we have to end up somewhere in between. But you got this case again that I mentioned earlier, that we split the components. We could try and just unmatch the whole rightmost part of the selector and store that instead of splitting it up into components. I also had a suggestion about using the selector with the highest specificity. In this case, for instance, we have to match both span and class B in order to match the selector. So if you just stored the class B instead, that would mean we wouldn't have to recalculate style for all the spans that didn't have B. Since it has to match both span and B, we don't really need to check for span. Yeah. I think I'm going to skip that one. So the current conclusion for invalidation sets is that we recalculate for a lot fewer nodes, but it's not minimal. But I guess we have to go on a case-by-case basis, figure out if there are cases in the wild that we don't behave well with currently and that we have to look further into. But at least it's a lot better than it used to be. Yeah, I got 7 minutes left, and I thought I'd just mention element-style changes as a last point. So currently we do a local style change for these style attribute changes, which means we actually do selector matching for that single element. But when you do change properties of the style declaration, in most cases, if you don't have any important styles, if you don't apply animations on top, you don't really need to match any selectors. You can just set that property directly. There are certain things you need to take care of, but you should be able to skip the selector matching. So somebody wrote a document about this. I don't remember where it is, but you know, Eric, somebody at Google wrote yeah. So I have actually experimented a bit with this, and I have a list of like 10 regressions. They are related to effective zoom, which is something I don't know exactly what happens there with the RenderStyle and effective zoom, but it has to do with that zoom property, propagate the product of all the zooms down the tree. But this should be possible to do. So if you remove a style property, that means you need to take selector matching into consideration, because if you just remove the color property from the style attribute, it means that there could be a color property coming from a style rule with selectors that needs to be applied instead. Also, important rules may be applied on top of style object properties, and animated properties are also they are applied during animations. They are applied on top of computed styles. And also, adjust render style needs to be done. If you change display type, float, some of these CSS properties cannot have certain combinations of values, so you have to do some adjustments afterwards. Yeah, this is just an example of the how an important rule would override a style declaration property. Yeah, so I did an experimental patch. It's not up anywhere yet, but these are the two issues I ran into: the effective zoom propagation in RenderStyle, and there was some test case with CH units. I haven't looked into that yet, so I don't know what it is. This is basically the end of my talk. So there's 4 minutes left for questions. Yeah, but that will actually end up as an invalidation set on the style attribute, so you will get the invalidation from there instead, I think. So that means, yeah, exactly. Yeah, that needs to be taken care of. Hopefully not many pages uses that. Huh? Yeah. Is that Adam? Yeah. Yeah. WebKit is, they actually implemented CSS JIT as far as I know. I saw a blog post about reducing it to half the time or something. I'm not sure. Jochen should be here because you are here. Do you have any news, Jochen? Sorry, was that maybe I should have faster what selector? You said people asking for faster.
Yeah, so there are some teams internally in Google that asked us for faster query selector performance. Yeah, the DOM API, but especially if you style people have some good benchmarks where you think like this is a realistic workload where we actually would benefit from faster selector matching, then I would be really interested to learn about this so we can, while we try to evaluate what would be a good API, also make sure that we're actually optimizing for a real workload.
Yeah, this doesn't apply directly to the query selector because, yeah, I've been focusing on trying to reduce the number of nodes that you actually look at, but yeah.
Yeah, so what I meant is like both query selector API and the selector matching, they both use the same backend internally.
Yes, you're talking about CSS JIT now, right? Faster selector matching, yeah. I just lost the... Yeah. Yeah, we have to quit now, says Max. Yeah.